and we are going to speak about the project that we worked for last 2 years together. And that project, it's MySQL Cookbook. There also will be, we will give one book away for the best question for this talk. And there also will be lottery, and if you are not the guy who asked the best question, you can also be lucky in the lottery. Our talk, it would be like we present our book, and we will do it in 2 parts, because this work, it was a war story, but it was individual for each of us. So I will start, and Alkin would continue. So who am I? I'm Sveta Smirnova. I'm MySQL support engineer for many years. And I'm author of another book, author of some programming projects, and frequent speaker. Here is my connect information. It's LinkedIn, Twitter, whatever, SlideShare. And to understand why it was war story for me, this book, I need to tell a little bit about myself as a speaker and as a support engineer. And I work with DBAs. Like most of my work is DBAs, and for events it's also DBAs. So people who administer the database. They do not write, usually do not write queries. They do not do any MySQL development. They just tune, and they just try MySQL servers to work faster and work stable, no matter which bad things their developers in their company did. And MySQL Cookbook, this is 4th edition, and the 3 first edition were dedicated completely for developers, for people who write queries, for people who make MySQL troubles, who do something with MySQL. So this was very challenging for me because it's a new topic. And also, before starting working as support engineer, I worked myself as a developer. So I was thinking, okay, let's go back. And so I accepted the offer. And then I accepted the offer. I started thinking what changed after 15 years when I was a developer. Well, we still write queries like this. And this is last part is intention. We can be save something, or maybe SQL injection. We can use placeholders and save ourselves from injections. We mix SQL and nice object-oriented, or maybe functional, or maybe whichever your preferred programming style with SQL. We can also use ORM. That I started hating when I started working as support engineer, because some underlying software changes this nice thing to some very crazy SQL. So was anything changed? Well, at the first glance, no, because you can still see this kind of programming. But we also have new MySQL APIs in version 5.7 and 8.0. We have native document storage support for MySQL. And we can use object-oriented query language for MySQL natively. So our topics today would be like, well, all the receipts, no, not all the receipts, but some receipts from the book. And many receipts would use our old friend, MySQL command line interface. Why? Because this is, it's my favorite SQL debugger. Because it's tested by 1 million of users, and all MySQL developers who develop new feature, they use this tool. And when for everyone who has troubles with MySQL, I say, please do not tune your application yet. First test it MySQL CLI. If it works correctly, this means that your application is false. If it doesn't work correctly, fix here and then fix in the application. But now we have another tool. It's called MySQL Shell. It's another client. And this client supports JavaScript, supports Python, and supports plain SQL. So you can see it's like on this slide. Besides that, what is good for this? It supports also XDF API. We will have on the next slide. It also has MySQL Server Administration. Anyone heard about new feature called MySQL in a DB cluster? Yes, for MySQL and DB cluster, what is it? It's actually group replication and MySQL shell. So that's how you administer it. It's same, it's like about MySQL replica set. And you can write your own application easily here as well. XDiff API is this, what is amazing about it, it allows you to execute a code asynchronously. So like before, like in standard client, you cannot do it, but with XDB API, you can do it. And also XDiff API allows you to work as usual, like writing SQL queries, but also query tables as document, and also work with collections like same way as you do with MongoDB. Well, it's not the same way, but very, very similar, and in my opinion, MySQL syntax is a little bit easier to learn for first time. So it's just like few examples. So like for reading queries, like it can be standard SQL. It could be a document store, so you are like you are just writing object-oriented code, and you can chain these calls as many times as you want. You can use its MongoDB style, so this is document store, and you can combine last two situations for querying documents, collections in document store as a tables. It's a little bit awkward, but it's possible. Working with result, it's here is code is not like standard Python. It's a code which uses XDiff API. So this is actually it's like well, it's almost same as you are doing with standard API. So that's you can read the data. You can use XDiff API for tables using this syntax again. So you do not need to have you do not need to use external libraries, and MySQL will do all that combination querying by itself. For document store, you can also use the same way as you do in Mongo, and you can combine both operations. For changing data, it's again you can do it in standard SQL. This is example in JavaScript, so again. Document stored for Python and combining things. For character encoding, unfortunately, this is I am originally Russian, and for me it's very important. And for standard API, there is no big deal for character encoding. You just specify any character set. You can also use set names command. It's exactly as you are doing. But with XDiff API, you can use only UTF-8 MB4. This is good. It works by encoding itself works perfectly with Russian, with Turkish, and with many languages. It still has some missing symbol in Korean, I believe. But it may just not work with your connector, and this is for Russian language, bug for Russian language, so you need to test. So this is downside of XDiff API and for local languages which are not English. Okay, so we are speaking about MySQL shell, about XDiff API, which also we added new to the book, which also we changed it to. The book first editions contained some recepts about how to resolve common tasks. For example, task is how to find the longest trip per driver. So we have 3 drivers Ben, Henry, and Susie, track drivers. And for example, Susie has her longer trip on August 2014. So how to find the longest trip, how to we do it without manual scanning? Naive solution would be to select run this query, but issue here is MySQL even would not allow to run it by default, because and reason for why because if we remove SQL mode, we set it more not so strict. We will see that for Susie we have some longest trip was happening, its number is correct, but it happened in July. But on the previous slide, we are seeing that it's not happening in July, it happened in August. So before 8.0, what you could do, you could create a temporary table, create like name, Max Smiles from driver, and then have this table with correct date. But this has downsides because you are creating temporary table. You would need to, if you want to keep this connection open, you would need to remove it. And also it's not atomic because that's tables. In 8.0, you can actually do the same thing, but use common table expression. Common table expression, this is something that's like, sounds like very complicated, but practically that's you are just creating like same statement as on previous slide. So you are creating temporary table, and you select from this temporary table, you name it like whichever name you want. I put here as T, and you are like using it, and you can just run a normal join query, and you get the proper summary. Another new feature of MySQL, this is built-in validation and validation checks. For example, we have many examples with table called patients. This is for imaginary hospital and sometimes for imaginary diseases like data phobia. Which is like, but what we need like for this, it still looks data real. Like patient cannot leave the hospital before he actually was checked in there. And so we can have this check constraint here. And we can have this like, it's before you could do what you could have triggers, but triggers it's more writing and also has some locking issues when you do it. We also do validating and formatting for JSON. So JSON is like schemaless, but what people want, they also want schema. They want some rules for JSON, so they do not put everything. So like for this, for table limbs, for collection limbs, we can define properties like thing could be type of string, and that's legs and arms are required fields, like here, but they have some default value, and they could be either number or null. And that thing cannot be null, cannot be null because it's just like type string. And then when you create a collection, so you just put here, so validation strict. It could be not strict, this could be like up to you, it could be not validation, this is up to you. And putting schema, it's schema that's we created on the previous slide, and so next time when you insert anything into this collection, it would be validated. Another thing, it's sequences. So sequences is like something, for example, we have a group of people who are going to participate in some competition. And they need to like go in turns, like when you like, for example, like it's running or riding competition, so they have to start, they cannot start like all of the over. And you want to create a queue. And for this, you can use window functions. So window functions, what is it? So this is some predefined set of functions, like in this case, roll number. And it's created over the win. And what is win? And win is like kind of query against the table. So you are querying the table, and it creates some results of this function. And you can have many you can also create sequences in one query without window function with common table expression. So in this case, you are using word recursive. And here I am creating like sequence, I creating geometrical progression, and I just creating random numbers. And you can, here it's like temporary expression, like select one, some start numbers. And here we are union with something different expression that selects from like from previous row. And then we select from anything. And here we must to have something where we stop, because we cannot do it forever. Another like the way which we can use a recursive CTEs, common table expression, it's to answer such question, how many drivers on the road. So this is, we have drivers and we have days, but issue here like July 31 and July 28 are missed. So we do not have days where we have zeros here. So how to solve it? We can create a table dates and insert missed dates. And then we have, like, for example, to find dates where no drivers were on the road. But this is, again, this is like kind of, we are creating temporary tables, you have to remove it, and this is not atomic operation. So with recursive common table expression, you can just create table dates in one query, like recursing, like from July 26 to August 2, and then you can have, you can use left join, and you will see the zeros on cases when there was no drivers on the road. And one more issue, like one more recipient I want to share is about ranking. It's ranking, it's like, for example, we have like some score. Some people like was participated in competition, then got the score, and we want to put them in a rank. So a legacy way is to have like variable and using this variable in the expression. So what is the problem with this way? It's deprecated. And why it's deprecated? It's because for this query, probably that's not big deal. But if you are using multiple tables, if you use a complicated query, optimizer can create different plan, even the four-step version, because you change the data and creates different plan, and you will have different numbers here. So we can use window function. So we have row number again over this window, and you will see that's perfect and guaranteed all this way. But what is the problem with window function here? Row number is that, for example, we have two participants who got a score 4, but they have different ranks. Actually, that's random. So we don't know, well, it's not now random. It's, well, since we are ordering by score, yes, that's random. We don't know which participant had rank 2 and then 3. For this case, we have a function called rank. That puts the same number for that participant who got the same result. It's another use of common table expression is to see, like for example, to find duplicate rows. So in this case, we are searching like for table catalog list where we have last name and first name, so it's probably users who obtained these items, who have, so they inserted more than one time. And we join it with the same table again, using, and we are seeing like all these users. And we see that these are probably the same user. These are also same user. Well, it's has apartment, but it's probably this again the same user, and we can make guess a decision what to do with these users. And final receipt that I myself want to show is like data type JSON. And data type JSON is it's actually that's because we have this data type. It's why we have collections in MySQL and why we can work with MySQL like with Mongo. This is compact storage. That supports in place upgrade, so like even for replication, so that should be enabled for partial JSON on the source and the replica. And so what mean in place upgrade? So like JSON document that could be like very big, and you want like, for example, it could like name, it's like Sveta, last name Smirnova, books is like MySQL troubleshooting and MySQL Cookbook, and you want to like, for example, update book publication date for MySQL Cookbook. And if it's not in place upgrade, it could be a full document replaced, but MySQL, JSON and MySQL supports only part of JSON that you are upgrading. It supports various functions like search, pattern support, updating, validating, conversions, joins of documents. It also supports operators for easy access. And let me show you. So for example, this is book table called book authors, and we have field author. And we can like just extract its author name. It's for MySQL Cookbook, it was Paul, who wrote first free edition, Alkin, and me. And you see it's like everything in quotes. And if we are using this operator, it also will, everything will be in quotes. It's as the string is written as JSON. But we can also use function called JSON unquote and have more user-friendly name. and either better that's operator that also allows you to unquote and put strings and better view. We can use path, and also like what I want to show you, this table has books stored as array. And for array, we can access first element, like array of books, like 0. And we also can access last element. And last element, you can see, like for Paul, he wrote tons of books. So you have like first book, it's software affordability, and like last book, it's this one. For me, it's MySQL troubleshooting and MySQL book. It's only 2 books I wrote. And for Alkin, it's only MySQL Cookbook, and it's the first book and the last book. So there is no error, there is no null, and it's completely visible. You can also have indexes in JSON. So how it works, you are creating generated columns like called last name. So it always generated as this expression and column's name, and you can see index. And when you like searching, for example, for books and for documents, JSON documents for particular person, you can search like call it in SQL, and access would be very quick. And now that's all my part, and I'm giving a handle to Alkin, and he will continue about his war story.
Okay. Well, thank you very much. So as you can see, she's flying through the slides. Does anybody remember any of that? There was about 60 slides that went through in 20 minutes. Well, thank you very much. This is going to be like a little shorter. So let's get connected first. If you're not, connected with me on the LinkedIn or Twitter, you can do that. I've been with open source companies previously, PlanetScale, Percona, and Python, as a manager and a DBA. So by heart is a DBA. I have also done enterprise database work in the past for one of the specialists in Informix, Oracle, DB2, SQL Server, and some others that doesn't exist today. So I am now an author, as you can see. Thanks to Sveta for that. And been speaking and mentoring and coaching a lot of people in this open source space. And we have been selected as open source database influencers of 2022 this year, as well as some of the other speakers over here, Ibrar and Peter. Okay, I also do some sailing, and the seas aren't flat like this in general, so this is like an Instagram versus real life. I chose the most peaceful picture. If you want to talk about sailing and exploring, and let me know. Okay, this is where I work. It's called ChistaDATA. It's founded by Shiv, and we've got some investment and more news coming up on that. We focus on ClickHouse and infrastructure and engineering. And what's ClickHouse? Does anybody know what's ClickHouse? All right, few people, that's good. We'll talk about that. And there will be more talks from me and some others about ClickHouse coming days. And this is what I am actually focusing on lately. So about ClickHouse, so as some people raised, it's a database, but it's a columnar store, not like MySQL. And it's SQL compatible. Peter mentioned on his talk about it has an interface for Postgres and MySQL clients. And it is open source, which is great. And it's got a bunch of other features that it's actually focused on analytics and OLAP databases or use cases. It's not intended for OLTP like MySQL and Postgres. So enough with that. So I want to talk about query performance and indexes. So I think this might be useful for many. And basically what Sveta mentioned, there's more in the book. This is chapter 21st, chapter 21 of the book. There's much more details about it, but I want to just cover this because previously I've done a talk about query optimization and indexes, and which was the most popular because it actually impacts both developers and DBAs. So we got indexing basics. I want to talk about that. A little bit new features on full text search and spatial indexes and geographical data. And using histograms is kind of new. These features are improved in MySQL 8. So they did not either exist in MySQL 5, 5.1, 5.5, up to 5.7, or they weren't really actually as strong as in MySQL 8. So what does the indexes do? It helps access data fast using table scan. It has algorithms to access data fast, and it maintains that. So we got a bunch of stuff, which also added the spatial, full text, and histograms in MySQL 8. So we can take a look at some of the features here, more details in the book. Binary tree is self-balancing. So this is the main indexing algorithm that is used in MySQL, and it helps full table scan and as well as pointing the indexes. And it maintains this pointers to the data so that you can actually access your data faster. But it doesn't do that very well if you don't understand what the data patterns are. So I went with a different format than Sveta's slides, because this is how it's in the book. So I like that this is what you're going to see in the recipes if you're looking at the book. So if there's a problem, and then there's the solution, and then there's the details about it. So that's how it is. In this case, most common problem in MySQL, if you don't actually have a primary key, you have a problem with the performance. It does create a clustered index by itself, but it's not as useful as the primary key that you can create. So basically, you go and create a primary key for all the tables that doesn't have a primary key. And well, how do we decide whether the query can use an index or not? You do an explain. So basically, this is the shortest and the fastest way. You run an explain on any query, and it'll tell you whether it's using an index or not. In the possible keys column over there, it says null. That means that there's no index. And then you basically create an index that actually useful for that. And also you can create a multiple column indexes, which is called in different terms. Some people call it a covering index. Some people call, there are different terms in the past. I'm old, so I've been in this database for a long, long time. So that means I've heard different terms for it, but multiple column indexes is I think useful, because covering indexes becomes a little complex when you have a lot of columns. And also now we talk about the full text indexes. So full text the question is whether full text is useful for the, sorry, I need some water, I guess. It's dry over here. Full texts were available in MySQL, in the MyISAM engine. Now that we are in a different world, that most MySQL installations use InnoDB, which didn't actually initially support for it, and then it came, and it came with a bunch of features. So, from the name itself, it's used on the text fields. When you have a large text in your database, it becomes a cumbersome to access that data without an index, or you don't actually find what you're looking for. There are different solutions in the large scale for full text searches. They index and evaluate, estimate data based on the words that are in, but you can actually combine them in MySQL. So there are different modes for full text indexes. One of them is the natural language mode, which allows you to actually search in natural language. And then we have an example. There are many data stores in the book that actually have examples for each recipe. So in this one, we've collected top names, and then we want to search for the top names in the world. That's what's used. An example that's used against a name that's called Andrew over here with a natural language. You can actually make searches. There's a Boolean mode. You can actually add, subtract names from that. So you have a text field, a use case that you can combine different combinations of searches. There's also a keyword search that you can actually do a query expression and then basically take advantage of this function in the full text search. Whether the optimizer will choose this index or not, the same thing with the other indexes. You could use explain to figure out if the query is using index or not. So in this case, we have an index that is created for that, and it is using. So we are going to show in this example, it actually uses the index that is not full text. By default, optimizer thinks that the full text indexes are not very performant, And so it uses the non-full text one, but you can actually create a full text index that is going to be more advantageous in the long run for that type of query. And then you can run an explain on it to see whether it is using that index or not. So we have examples. So the next subject over here after the full text indexes, how we're doing with the time? Good. Spatial indexes. So this is MySQL's one of the biggest projects during the MySQL 8 launch. Actually, the geographical system that was used in the previous MySQL versions up until 5.7 were not really up to the standards. So there was a little bit behind, coming behind in the market compared to Postgres. Postgres had much better functions and support for geographical indexes and the reference systems that was fully basically rewritten from scratch. And we've seen the evolvement of this, so we want to take an example. So why do we need this? Yes, there are actually very large-scale companies use this as a feature now. All the online e-commerce sites, I don't want to name names, but there's Uber and others like to use MySQL for this system. So they need to know the location of what they are actually purchasing, where it's coming from, where it's going. So keep track of that. All the IoT devices in the world, including the scooters that you rent on the street, has a latitude and longitude, the geography location. So the GPS locations need to be kept somewhere. So you can do that in MySQL using these reference systems and functions. So it does come with many reference systems because there is not really one spatial reference system that everyone uses, but there are some generic ones. So the most popular one is, as we all know, is Google's. Google Maps uses this system called 4326. It has an ID and then there's a definition of it, so you could see that. If you're interested on this one, there's a good reading about those, and then use this 4326 as a reference, and then you can create basically objects around using this reference system with the coordinates, latitude and longitude, which will equate to what Google Maps use. So the problem with the reference systems is you actually have a system, locations, which is standard, latitude and longitude, the GPS coordinates, but then when you put them on the map, they don't show properly. And there was a huge improvement in this system on MySQL 8 for the three-dimensional system, because world is not flat. Or is it? World is not flat, yes. That's why, and you need a three-dimensional system that will support. So with the latitude and longitude, you get the coordinates, including the three-dimensional. Otherwise, if you place a connection on the map, it becomes either in the wrong location or it's a shifted position. So we actually have an example over here to insert point of interest table with the coordinates that I actually gathered from the Google Maps. So we have Maiden's Tower and Galata Tower. Both towers are in Istanbul. So, and then you actually create an index that references this system. And then you can select these points into a location, and then using the spatial reference system functions, you can measure the distance. So this distance will be like a flat line between the two locations. But if you had a different function called distance sphere, this is the improved function that'll show spherical difference. It will measure the difference in, this is in meters, how far these two towers are. So these are examples that you can have it on use cases. Let's say we have a polygon of coordinates, so randomly selecting 4 points with the coordinates, you get a polygon set up, and then you can actually search within this polygon, saying that position and what are the points of interest can be available in this location. So we are all keeping this in MySQL in the database with a spatial reference system that is known by the Google and others, and then you actually can query all that. So you can integrate this into your application, whether it's small or big. So we also have, don't have much time left, but we also have histograms example over here, which is also a great addition to MySQL 8. You can use histograms to create buckets for your large data sets, and the query optimizer will choose the better solution for reaching that data. So there are some examples over here using information schema from the column statistics. You could get the histograms, whether you have different buckets allocated, and then basically you can compare the query before the histograms and after that. Sveta has an amazing talk about details on the histograms. If you want to explore histograms, you can look at that talk. So just coming to the conclusion, you need to study how the MySQL accesses the data to find right efficient queries. So DBA's nightmare is not the slow system, is not the small systems, is the bad queries. So the bad queries actually slows down everything. Basically, that's what it is. You need to find the optimal method, check it if it's used, which is the explain, and then estimate the cost of the access method, and there will be multiple ways to reach the data. Whatever it is most optimized will be the fastest, and then you use that. Basically, MySQL uses basically a table scan. By default, the optimizer says, hey, use this index if available. And then it will do an index lookup for points when they were close. You can do a range scan, index merge, and loose index scan. These are the main categories of indexes, how the MySQL uses indexes. So basically, by studying the most frequent used or the slowest queries, you can actually optimize them doing that. In conclusion, the slow queries can be caused by these, basically the low cardinality, large data sets, and even it could be a MySQL bug. So you have to study that. Okay, and thank you very much for listening and coming for today. And we will have a question, and the best question will have this book signed by the authors. Any questions?
Hello. What programming languages does XDev API support?
XDev API support is Java. It's JavaScript. It's Python. It's, I believe, C. It's actually there are some community projects for XDev API for supporting languages.
And does it require server-side support or just only client?
It's client. It's client.
Only client. Okay. And how much of what you've talked about, like all the new features, how much of them are also available in MariaDB? As everything, or?
It's like, for example, which I talked about, the window functions and commutable expression were available in MariaDB. It's there. It's actually we are arrived in 10.2. That's before MySQLs. Speaking about features that we explain in the book, some are available and some are not. For example, XDev API, actually, I'm not sure if it would work for MariaDB, but probably it's worth trying. Like MariaDB, because like they port some features into their server, and they some features they re-implement, some features they implement absolutely independently.
Previous slide, you make an create table and down temporarily table.
Yeah.
And then drop it. Why they use like that? Because I am use create in table in query, then as a temporarily table, then use it where etc.
It's actually why I drop it. It's like it's just example. So like what just happened? Like I showed, like we have some main table. We need to get data from it. But we need to use it only temporarily. It could be like it's dependent from your application. You can create like permanent table and just update it, like for example every hour. If you that's a main table like updates often, you may probably should not do it every hour, but like every 15 minutes or maybe every 1 minute or maybe even session. But what you need to do, you need to like what's much because like I cannot like make movie for this. But what you need to do, you need to care about this temporary table. So you need to create it. You need to think how it would be dropped. If you use word temporary, like when you close the connection, it's dropped. So you don't need to drop it. But if you are using that connection like for a long time, and using persistent connections, you may have side effects that you do not want. So you need to care about it.
Okay, a second question is, there is a limit to subqueries, because I love subquery using, but worrying about query execution time.
About performance, for subqueries and MySQL and MariaDB, they both did a great job for improving it. And like if you are doing like, if you go like to bugs.mysql.com, you'd say you will find some like queries that's like says like it's fixed at 5.6, fixed at 5.7, fixed at 8.0. So for now, I suggest subqueries sometimes it's much easier to write than join. And now MySQL Optimizer can, if it's needed to convert to join, it converts it to join. So like in this case, I suggest you to always test. And like I believe in 8.0, it would be most of subqueries would work fine. It's sometimes even join would be slower. I saw such cases. I don't have them in my heart, but I saw such cases. Always test, and there was a lot of improvements. The 5.7, 8.0, there is no big issue with subqueries.
Any other questions? Okay.
Thank you. I just want to ask, in my previous company, we used storage procedures, and inside of that, we used so much temporary tables. And we had so terrible RAM issue. In storage procedures, do we need a temporary table to reduce? Should we use query optimize?
So it depends on the version. So actually with storage procedures, you have few issues. First, if temporary tables, it depends like storage engine. It could be on disk or could be in memory. If it's in memory, of course, it would use memory. Second, storage procedure itself, it has some cache. And we had like a bug. I believe it fixed it in 5.7. It was like it's sometimes like if you have like many storage procedures that you execute, it's fill up cache and there is also memory issue. So like it depends on like how big a storage process, I mean how big SQL code. So this is not about like how much data it changes, but it's about like SQL storage procedure code itself. So you need to investigate your exact case,
Is there any flex to disable that cache or something?
No, there is no, but it's optimized in latest version. It's again, like if you want, we can go to colors and we can search for that bug together. And it was it was reduced to some smaller numbers. So it's like in latest version. So in which version you are in?
5.7, as I remember.
Okay, so if it's latest, well, it should be something different, but and your temporary tables are in memory or on disk?
Memory.
No, in memory, that's logical. Like if you call that temporary table in memory, it would use memory.
But also, we are using a memory, but in the end, I will select that also. That query result will be stored in memory.
Yes, query result, yes, but query result, once your client receives it, it gets discarded. If it's in temporary table, it stays until you drop it.
Yeah, but even I can delete immediately after I used that data. Is it also difference between of them? And inside of third procedure, as you say,
it should not be. It should not be. It's what is like again, like what it's again. I'd like maybe ask you to come after. That's
yes.
Like
okay, we're
in the coffee break, and that's like make a test. So like for example. Like you are creating a temporary table, put some data, and remove data, and watching like how much memory, you measure how much memory MySQL uses. You create temporary table, you put data into it, you drop it, and you measure again and see the difference. Then you create a storage procedure. You measure how much memory MySQL uses. You run the storage procedure. You drop that data and you measure again. And again, don't forget to run flash tables, because probably flash tables, that's the case.
Okay, we are out of time.
Okay.
Thank you very much for the questions. You can
Thank
catch
you.
us after the talks.
Okay,
in
so
the coffee
actually-
breaks. What was the best question?
Actually, we need to find what is the best question.
Okay.
So I think that's you.
Okay, you got the book. Thank you very much, everyone, and we'll sign this for you.
Alkin, wait a second, we need to sign. Okay.